All right, so this is worksheet 8, problem 3a. Suppose phi is a strictly increasing continuous function that maps an interval capital A to B onto lowercase a to b. Suppose alpha is monotonically increasing on lowercase a to b and that f is integrable on that interval. Define beta and g on capital A to b by beta of y is equal to alpha of phi of y, and g of y is equal to f of phi of y. And we want to prove that the integral from capital A to b of gd beta is equal to the integral from lowercase a to b of f d alpha. And we started out by drawing this little mapping here that shows from capital A to capital B mapping onto lowercase a to b. And we have a couple key important things we're going to use later on in the proof. Beta of y is equal to alpha of phi of x, and g of y is equal to f of phi of y. Now we're going to start out by creating two partitions. We're going to create partition Q of capital A to B, where Q is equal to y sub 0, y sub 1, all the way to y sub n, and that corresponds to partition P of lowercase a to b. So P equals x sub 0, x sub 1, all the way to x sub n, such that x sub I is equal to phi of y sub I for I equal 1 to 2 to n. Now, by definition, the upper sum of Q is equal to the summation from I equals 1 to n of the sup of g of y delta beta I. Now, g of y is equal to f of phi of y, which is equal to f of x. And delta beta I is equal to beta of y sub I minus beta of y sub I minus 1, which is equal to alpha of phi of y sub I minus alpha of phi of y sub I minus 1, which is the same as alpha of x sub I minus alpha of x sub I minus 1, which is delta alpha I. So we just showed that the upper sum of Q is equal to this summation, and then which is the same as this summation, which is the same as the upper sum of P. So therefore we showed that the upper sum of Q is equal to the upper sum of P. And we're going to do something very similar to show that the lower sums are equivalent. So the lower sum of Q g beta is equal to the summation of I equals 1 to n of the inf of the set g of y delta beta I, which is equal to the same summation from I equals 1 to n of the inf of f of x delta alpha I, which is equal to the lower sum of P. So we showed that the upper sum of Q is equal to the upper sum of P, and the lower sum of Q is equal to the lower sum of P. And since f is integrable on lowercase a to b, the integral from lowercase a to b of f d alpha is equal to the inf of u of p, which is equal to the sup L of p. Now the integral from uppercase a to b of gd beta equals the inf of u of q, which is equal to the sup L of q. So therefore, the integral from a to b of f d alpha is equal to the integral from capital A to b of g d beta.